Everyone, for our now concluding sessions of this year's AMTC 2022. Always goes so fast in the afternoon. I'll just let those who are still coming in take their seats before we begin this session on regional similarities and differences. And maybe we can just get those who are still standing in the back to please take your seats. So, after zeroing in on the different regions in the last three sessions, we want to try to use the remaining sessions of this year's conference to zoom back out and look both at an overview of regional differences and similarities, trying to tease out some of the commonalities, but also some of the discrepancies. And then we're going to take a deep dive on what many of you consistently cite as an area of particular interest and also promise for AM, namely sustainability. So let's talk about how the regions stack up when we compare them. We want to do a deeper dive now on those issues. And we have a great panel with us. It is now my great pleasure to introduce, starting from over there, Martin White. He's head of additive manufacturing programs at the international standard setting body ASTM International. Next to him is Professor Dr. Johannes Henrich Schleifenbaum, very familiar old friend of the AMTC, an old friend and partner. He's chair of digital additive production, DAP, at the AMTC partner, the RWTH Aachen University, one of Germany's leading technical universities. Next to him is Damian Buchbinder. He is the head of product management, additive manufacturing at the international work tools manufacturer Trumpf, and he has kindly agreed to jump in at short notice for Andreas Frahm, Director of Global Laser Technology, due to illness. Mr. Frahm couldn't be with us, so we're very grateful to you for being available at such short notice. Seated next to him is Professor Dr. Christian Seidel, head of additive manufacturing at Fraunhofer Institute for Casting, Composite and Processing Technology, the IGCV, and also chairperson of the ESO committee TC 261, which, of course, is additive manufacturing. Great that you're with us once again. Welcome. Thank you. And next to him, also a returning guest, very glad to see once more, Paolo Gennaro, head of advanced additive technologies at the Swiss-based turbine engine precision parts supplier GF Precicast. And finally, Dr. Dirk Simon, seated next to me, is Managing Director of Farsoon Europe, which develops, produces, and supplies 3D printing systems. And he also serves as a member of the global management team of Farsoon's holding company in China. And I'd like to begin, as we have in some of our other sessions, by polling the audience. So, dear ladies and gentlemen who are with us either online or here in the room, please get ready to answer our audience poll. Here's our question. And I'm assuming that all of you are still online with your phones if you're in the room, and otherwise, of course, our online audience has the tools right at hand. Here's the question. Which is the industry that mainly drives the acceleration of metal AM on a global level? And we're asking you whether you think it's space, aero, automobile, oil and gas, or other. And I'll just give that some time to play out. We're just going to give this a few moments more. Okay, and we have the results. We're going to get it up on the screen right now. So as you can see, 48% say it's space. That, of course, is something that was reflected in many of today's presentations. Another 14% see aero as a key driver, so put those two together, and of course we then have 62 saying it's aerospace. Beyond that, 19% automotive, and another 14% say other. Interesting to think about what that could be. We did hear that maritime presentation earlier today. And then oil and gas, just 5% see that as a key. So let me start out by asking our industry speakers to comment on that. And I'll begin with Damien Buchbinder.
Yeah, so to be honest, I'm a little bit surprised. Space, yeah, I agree. It's everywhere you read it, you see nice applications. But that aero is not on the second place, there I'm really surprised, and that automotive is getting on the third place. So this we could discuss here in the round a little bit. Why is it? Is it because we are in Munich and there are nice cars, producers surrounding, and I don't know. Oil and gas, I'm fine with it. And the other question I would raise, what is in others? Because typically, if we talk about AM, I'm totally missing medical here, for example, especially dental implants, individual implants, serial implants. So, and another question, but we have here two colleagues from R&D, is perhaps not university, R&D, science, pushing our industry as well? This would be a question as well.
Yeah.
So I agree to space, and I have some questions I would like to discuss here.
Okay. What else would you put in other? You told us dental, health.
Medical, yeah.
Yeah. That'd be the main one?
Medical as a driver is strong. They have a strong footprint in Europe and North America. This is an industry since 15, 20 years, really industrialized. Right. So they do already a lot of serial production and they still push it. So for me, it's a must that it should be in the top 3. Mm-hmm. Okay. And if you look on the materials deeper, titanium is #1 material used in the AM metal sector. So aero is using titanium and medical, so should be an impact for this poll.
Okay, good. Let's see what the other industry speakers think. Paolo Gennaro.
Yes, I agree. I believe for our side, most than 50% is orthopedics, basically driven by titanium material. Remaining is, we can group probably in turbo machinery, where turbo machinery is jet engine, industrial gas turbine, and turbo pumps. Rocket is space is turbo pumps at the end of the day. And in terms of material, probably, and for sure, for orthopedics is titanium, and for the other is nickel base. But I believe we have also to divide in terms of class of machines. The small machines produce a small part, typically orthopedics, so typically titanium. For the large machines, also in our portfolio, is more turbo machinery working with nickel-based materials. And then there is also probably the next step with this big machine working with aluminum for structural component, or maybe also for titanium. But for us, for our business in terms of sales, I would say 70% orthopedics, 30% with large machines with turbo machinery.
Mm-hmm. Dirk Simon?
Well, maybe this poll shows a little bit in the recent past. From my point of view, also with the presentation this morning of the photo of the futurists of this, what Kai presented, health is certainly underrepresented, which really drives acceleration. Driving acceleration looks in the future, and here I see automotive. Automotive is a real trend, also for metal, to push now the systems into the next level where the cost is getting acceptance.
Thank you very much. Let me go over to the research and standards contingent and hear if they also see it differently from what we see in that breakdown from the audience poll. So, Martin White, you perhaps first of all.
Thank you. So I think from the comments, it's a difficult metric to perhaps classify. Purely from a standards perspective, only a few weeks ago in Augsburg, we had the ASTM F42 ISO joint committee meetings. And I think it was clear to see there that in terms of acceleration, we're seeing some advanced level standards. So in particular, recent standard on part classification for aerospace, which is now looking at how we apply risk when assigning applications for additive manufacturing parts. We also see through F4207, which is an applications committee, that aerospace and space are probably the most active, but I think medical is not so far behind and also looking to get more involved. So I think standards perspective, the applications, not too dissimilar there. From ASTM perspective, we also run a research to standards where we're trying to accelerate standardization. And interestingly, the ideas for standardization come from the audience, the community, anybody working in additive. And over the last 2 years in particular, we've seen the trends in where the ideas have come from, focusing on things like simulation and data. So whereas a few years ago it was things like test methods, we're now becoming more advanced in the way we use additive, perhaps. So I think maybe we see that in some of the trends as well, some of the ways we use the applications, not just in the industries we see.
How do you see it, Johannes? Would your perspective conform to the poll or not?
Yeah, I mean, pretty much I'm okay with that, what my predecessor said. I think medical is there. Once we remember, I think it was AMTC, or at that time was MTC 2019, we had that nice presentation of the hip cup in a box, which then it was totally digital process chain, all the way from the scanning for the data preparation and the printing. And there was a medical doctor showed us here, and I mean, maybe we're all a bit event-driven, and if you have to ask the same poll, then medical would be more represented here, I guess. For the event-driven case, but they are in some cases in stealth mode. I mean, they are doing that, like you said, for 20 years or even more in terms of research, and they are there, but they don't necessarily tell everybody what they are doing. Because, I mean, it's a highly regulated market. They try to keep the secrets inside their houses. They are not using frequently job shops. They're doing the production more or less on their own. And that's a bit of an issue. I see still what you also mentioned is that R&D today, which is also missing, is driving the industry to a very high degree. We see many machine sales into the R&D world, especially here in Europe, but increasingly also in the US, and to come to some regional differences, also in Asia Pacific. When I talk to my partners, and I see that as a major market as well. Still, it needs to be transferred into industry because we're doing research, we're not making business cases and money. So the question is how sustainable this is.
And finally, Christian Seidel, also whether your take would reflect what we just heard there.
Yeah, there were very interesting perspectives from the speakers on the panel. But maybe one thing that could be mentioned is the numbers we saw on the screen a few minutes ago. They were kind of very interesting because if you refer to leading industry reports, they are little bit of there's a difference to be observed. First of all, well, medical. I think medical, according to AM Power report, is 16% of the industry's revenue, and Wohlers, I think, 17%. So they kind of they kind of have a similar opinion on the strength of medical market. So it's one of the leading markets in the industry. Space and aerospace is in Wohlers summarized to 17%, I think, and in AM Power it's split in space 9% and aero 7%. So we see a big gap between the poll and the leading industry reports, but this can be explained by the very impressive examples we see from the space industry. I really like these trusted chambers they print, so they might bias our perspective here a little bit. But again, I think these are the hard facts. Also, I'm not surprised about the automotive industry being on the second place here in this poll, because it's not as spectacular as we see it in the space industry, right? But it's so impressive to see how many parts are being printed in the automotive industry. And automotive is obviously a mass market. So once they find an application, it's good for the industry, for all the players in the industry, software, material, machines.
Let me now ask you whether you see, either from what we heard today in the regional sessions or just from your own work, whether you see a real difference between the industry drivers from region to region, whether your answer, because that was essentially, we had asked the question about global drivers, and I'd like to break it down now to the regions. So who would like to take a first stab at that question?
Maybe I can take a perspective, if you don't mind, from not only the R&D side, but also, I mean, lots of these startups that we create are created from universities, from research institutions. And if I may focus for the first time on that, for the first shot on that, I think startups are totally different across the globe. I mean, we here in Europe tend to be a bit small thinking, I guess. The cap table is typically a bit smaller, the ambitions are a bit smaller, and investors typically look into risk minimizing investments, meaning when are you cash even? Where total turnover, total revenue stream is not so important. And if I look to the US, it's totally different. You get more money, you get it easier, you get it on a larger portion. And it doesn't necessarily mean that you have to be cash even in, I don't know, 2 years or so. But that gives you more power to be more ambitious, to be bigger. And that's why they form larger things out of nothing, we would say in Europe. We are way more conservative. And I think from my perspective, Asia Pacific is playing a role in between. They tend to be more a bit in the US style, but they also try to get a grip more on the European perspective. And I don't want to judge which one is good or not, but I see from the R&D developing technology throughout the TRLs into companies via startups that there's a whole lot of difference, and that is also reflected by the governmental funding. We tend more in Europe be on a micro level funding, whereas the other parts of the world tend to be on more bigger projects, trying to get more partners and more things on the street in a larger scale. That's my perspective from a research side.
Yeah, we certainly heard that in one of the presentations from Singapore, talking about that enormous ecosystem that we're all involved
Absolutely.
there. So who else would like to weigh in on that question? How you see the regional, please, Dirk.
Well, additive manufacturing was invented in America, in Europe, and in Japan quite simultaneously. And then it developed quite faster in Europe and especially in the US. Europe was a little bit behind US, and then China jumped into it. And as typical, China tries to learn from the Western countries and it took up this learning. And the learning was, starting with the parts where cost of production is not so sensitive. So for sure, aerospace directions and medical directions.
We heard that so clearly in the film that said it's not about cost, it's about weight.
Yes, exactly. And this was speed up then in China, but now they are up to speed. And now I see this driving also from China. The sales of within China is even stronger than within US. Additive manufacturing overall. So this means that they are really driving within now the next step for cost-reduced, cost-sensitive applications, which is automotive and molds.
Just because you do have that perspective also from Farsoon, from China, from Asia, can you say a word about government support and the degree to which that also is accounting for a significant dynamic there?
Yeah, for sure. It was about 2011 that China put additive manufacturing first time in their 5 years program. It was Barack Obama first time putting, I think 2012, 2013, something like that, America Makes. And recently Biden with Forward AM initiative, America is continuing with this continuous support in this direction, while in China, the current 5 years program doesn't mention additive manufacturing anymore. So the government support was more like in the early days, 2011, the first 5 years, from that onwards, towards mainly in the research directions, in R&D directions, but now it's really industry driven in China.
Mm-hmm. Okay. Do others see it similarly? And if you take a look, for example, at the actors driving industrialization in the different regions, what do you think is unique perhaps in Europe? What is unique in the US? Martin?
So just to build on that, I guess there's a certain level of maturity which a region will meet. We recently did some work looking at developing a national roadmap for the Czech Republic, which is obviously very close to here. And even in the short geographical distance, we were able to see that the applications will quite often drive the industrialization. So things like tooling and kind of that entry-level application use, which is the enabler towards automotive and nuclear. From maybe the wider perspective in the US, I think the driver is, we've seen some of the similarities we've seen several times today around making a supply chain resilient, education, workforce development. These are quite common things in either very experienced, mature regions, additive, or maturing regions. US, probably the UK, Europe to a certain degree, there's a large amount of funding because it's seen that additive manufacturing, and in fact, advanced manufacturing is an enabler for job creation and building industry and economics. And you can see a number of, even last week there was a US release, advanced manufacturing strategy paper from the White House to the President, and that complements the AM4 program. In Europe, you have Horizon, which is actively pushing additive manufacturing as well, and the same in the UK as well. So I think that government and the funding is crucial to drive.
I would like to add something, because I don't see only similarities. Yes, we have aerospace and medicine industries everywhere, but let's look on defense, for example. For me, right now, it's focus North America, defense. We don't see it so much in Europe. Asia, perhaps you can more refer to this, or China. In Europe, you see more a mature dental market, and East Europe and a little bit Asia. And then there are some other points you should look at: investment criticality. East Europe, Asia, you have some customer in dental as well, but they want not to invest so much. So there are, in terms of quality of the products, in the markets difference between the regions. Yeah? And China, of course, there is an aerospace market, but as a German machine supplier, builder, it's a restricted market to get in. So for us, it's difficult to play their role. Yeah? So there are other influence factors we have to look at. But medical, aerospace, these big things, they are globally in the world there, but there are some differences.
Regional discrepancies. Yeah. Let me go to Paolo.
I believe this is coming from the story of additive, because additive for metal material start in Europe and start with orthopedics. Then move to the US, but only because the US takes more time for the FDA approval. So it's it's depending from the local rules coming from the government. And then move to China. And China is growing a lot because the Chinese are simply much more than European and Americans together. Same, I believe, is happening with turbo machinery, starting in Europe, but because the majority of aero engines are coming from the US, is moving to the US. And then because this space economy boosted by SpaceX is getting a lot of visibility, seems that the US is very advanced in turbo machinery, probably because they want to produce some company one engine a day, so they need more capacity. But I totally agree with you. In China, for European supply is difficult, because for aerospace and what is defense, they want to be independent, they want to have local machines, because they're afraid that sooner or later somebody will raise his hand and say, okay, you can't sell there anymore. While for orthopedic, they keep on using our European machines because they believe they have an advantages in FDA approval on the approval for these orthopedic applications. So, as I say, locals rules in most of the cases are a driver to move the development, and also the funding for defense. Probably we'll never know where DARPA is putting their own money, because also in China, I see the report from Terry Waller. It seems that China is the biggest market for additive. What they're doing, probably a lot of with local machines, some military or rocket applications, because you see in the inventory they promote these very large machines, probably not a lot of laser, but very large machines, what to do. So, again, probably defense are putting money in some application where the majority of the people are not allowed to know where the machines are going. So, against rules for the government.
I want to just remind the audience that we are eager to hear from you, dear ladies and gentlemen. So we will be taking questions in another 5 minutes or so. So please start thinking about and sending us your questions if you want to use the online tool. Or if you're in the room, of course, we will also take questions live. Let us look toward the future and talk a little bit about the levers that will bring AM forward, both within the respective regions and then also on a global level. And Christian Seidel, maybe you can get us started with that. What do you think is especially crucial to accelerate industrialization in a meaningful way? We ask this every year, but let's ask it again this year.
Yeah, no, it's an interesting question. I mean, first of all, similarities between the regions. In my view, I would like to echo what the speaker from Singapore said earlier today. She said that if you want to print an aerospace part, pretty much similar boundary conditions all over the world, right? So you have to deal with the same challenges. And I think that's an interesting message. So the similarities between the regions you were asking is like that we all have a kind of equal level of potential across all the industries. And I think it was quoted before, I felt honored by all the quotes from Kai, by the way, that I believe there will be growth across all industries for AM. In none of the industries, we've fully exploited the potential. So for that reason, similarities are, you still have a lot of potential in all your industries, in every region, and the challenges seem to be similar. There are some tiny details, political-wise, but that's to be mentioned. And now you were asking what are the key drivers, and I would like to say that in my observation, it is the what I call aggressive leaders. We need aggressive leaders in the industry who really have the wish and power to exploit additive manufacturing use cases. Because today it's fairly easy to argue why you're not using additive. You can always use injection molding, for instance, or you can use die casting, whatever, because you will have certified processes in your company, and everyone is settled with the cost calculations behind. But in my view, you need to have what I call aggressive leaders. They really need to want to implement additive manufacturing and need to take a little bit of risk in the discussions and in the battle of the multiple manufacturing technologies.
Can I ask you whether, because we have somewhat different economic outlooks for the various regions.
Yeah.
We certainly are looking at Europe sliding into recession. That seems pretty clear. The US wobbly, but not quite, not quite evident whether they will definitely be going into recession. And for Asia, we're seeing some of the lowest Chinese growth that we've seen in quite a while. So Dirk looks like maybe he wants to disagree, but anyway, how do you think that will influence industry leaders' ability to make the case for AM? We said earlier today that perhaps AM is a solution for things like supply chain disruptions and so on. Possibly, though, that's also wishful thinking, because it's sometimes hard to make the case for new technologies and investment when you are in a recessionary environment.
I know, So we need more aggressive leaders than the rest of the world, probably. That's for sure. It would be good. The revenue distribution currently is that we make 33%, about a third, in the US, 14% in China, and for instance, I think 5 or 6% in Germany, depending on the reports you're consulting. So in addition, every second machine is either sold to US or China. So the differences here are for me that we can expect the two mentioned regions to be on kind of a fast lane. In Germany would be the left lane. So we can expect them to make a bit potentially faster progress because they have the capability to invest more into the technologies. They buy the new machines. They are more powerful than the ones we have installed already in Europe because they take the new ones, the more productive ones. But still, I think it's really crucial to have these aggressive leaders who really want to bring AM into the company and who have the foresight to acknowledge that it might take time until you can fully leverage potential of AM.
Who else would like to weigh in on drivers, levers that will accelerate? Damien?
Yeah, beside the aggressive leaders, champions, whatever, I still see many influence factors surrounding the application. Finding the application, people who are trained, educated. So for me, still a driver is we need more people thinking in AM and being capable. And we heard it several times today and yesterday. It's not only the young engineer coming into the company. It's not enough. We need even tools that we compare conventional methods, production methods with AM. It's complicated. I'm pretty sure we all here, 5, 6 people, would make directly a mistake if we got a part on the table and say yes or no. It's not easy. You need an interdisciplinary team to answer yes or no for AM. So education, training, this is, by the way, my point why I think R&D is still important. R&D needs machine, that people using machines and that see it, how it works, how it does not work. Yeah? So training, education, R&D, we still need this push that the overall AM market, no matter plastic, metal, is going to be bigger. So this is still, for me, a big driver. And mind change, and perhaps some cultures is a different driver as well. US, perhaps in comparison to Europe, are more aggressive, more open to risk things. So this could be another driver, cultural differences.
Thank you. Paolo?
I have two things in mind. When I started this business 20 years ago, there was typically a lack of standards, basically, because I believe that a machine that is produced in China, in US, or in Europe must speak the same language in terms of standards. For this reason, 20 years ago, the first thing that was started to have international standardization. So a part that is produced by additive must be safe to fly or to go into the body in Europe, US, and China. So the first problem that I had 20 years ago, there was no standards. Now we have the standards. I believe it was done a very good job with ASTM, ISO, and the British standards. Now we have the standards, so everybody was talking the same language. That is the base, no? Then, why go into additive? I believe the answer is always the same. Cost saving. Yeah. Nobody will invest to improve the cost, to have more cost. Everybody will invest for cost reduction. For this reason, for me, one of the drivers is cost reduction. So we need more productivity and integrate additive with subtractive, because we have to keep in mind, as most of the people were talking together, that we sell or put into a component that is a finish, not only additive. Additive, in most of the cases, 20–30% of the added value. Then with post-processing, the inspection, the treatments. So we have to focus on productivity in additive is important. So bigger machines, more faster machines, but we have also to keep in mind that we have to make a post-processing that is weighting 70%, where in post-processing there's also the inspections. So in aerospace, in this turbo machinery business, but also in orthopedics, where the driver are basically the same, the quality of a part that is going to the body is not less than the part that is flying, very similar. So we have to invest there to reduce the cost, and so we'll go from a niche to a big market. But if we are not reducing the cost to produce the part, not the cost of the machine, but the cost of the application that is produced with this technology, the market will not grow. And I agree with you, in the past, the people, the knowledge of additive was very small. But now it's easy to find people that have an idea, at least. In the past, 20 years ago, the people has no idea. Now, with idea, with a lot of schools in Germany, in the US, everywhere, now people has an idea in the university they study additive. So, for me, it's like the standardization is done. The majority is done. We can improve, but it's done. But if we are not reducing the cost in production of the application, we will stay in 20 forever.
Johannes wants to weigh in, and may I just ask you, Johannes, because I'd like to pick up also on Damian's point about training and thinking AM as being a crucial driver. So in Germany, we like to think that the vaunted German system of close interface between industry and academic institutions can help that kind of development. Would you say that is a lever in Europe that is perhaps stronger than some of the other regions?
I don't know whether it's stronger than anywhere else in the world, but I definitely would say that this is a lever to boost the system. But what I see is, and there I disagree, is it's a point, yes. But the problem is that we always end up in linear thinking. We expect, as human beings, with our limited brains, that we can extrapolate the past linearly to the future, and that will be reality. No. I'd say, hey, if we think, I mean, I don't like the word part identification, although I use it, because if we identify only single parts, we will never, I mean, we saw the examples. There are assemblies, there are functionalities that need to replace. We don't need to be parts replaced. And we need to start from scratch, and not only in the product space, but also in the supply chain space. Because what we normally do is to take one brick out of the wall and try to replace it by a more or less similar brick and expect the wall to be better, to be more stable, to be somehow better. We need to rethink the system from scratch, not only part-wise, but also supply chain-wise. I mean, everybody's talking today about digital warehouses. And then you typically, if you ask people, hey, what do you mean with digital warehouse? Hey, you store only data, normal parts, and then you just ship the data. No, I mean, we've got role models like Netflix. We don't send the data. We just stream them and buffer them and control how many parts are printed, new formats are needed. We need to really draw a picture how the future should be, more or less on a no boundary conditions, no gravity case, and then fold it with reality, and then see what competencies are needed. And I think this is the main and biggest leverage. I know, and this needs really strong leaders, because these cases cannot be calculated on a spreadsheet. It's not possible. And that's why I admire the US, because they get inspired by an idea, they put money on that, they know that this is risk money and that they can fail. Hey, but if we don't try, we'll never know. I mean, it's a bit of a It's a bit of a no-brainer if I invest $1 and want to have like 1,000 back, that there's no risk in it. This is, I would say, dumb. And that's why I see that there's a bit of a difference. We need to have all those things, but these are linear and incremental improvements which we have to take. And this is what we typically know from shop floors, the continuous improvement, CIP processes. But on the other hand side, we need to really have a vision and a new system which cannot reflect the past, which have to be new. And this is, I think, the main leverage if we want to really have a disruptive system.
Let me now, we have very little time remaining on the clock. Let me now ask all of you to please now jump to the international level again, and very briefly, as a final word, talk about collaboration. And I'll just say, by the way, that we got one comment from the audience saying that there is another application that should be in that other category on the poll, and that is telecommunications equipment. Certainly a contribution there. So let me go straight down the poll. International collaboration. What is the single most important international initiative that could drive industrialization forward? Martin White?
So, Christian, give me a little smile then. So for me, one of the things we're kind of touching on is a rising tide raises all ships. And actually, there's two mechanisms by which we can do that. One, which is standardization, another one, which is education, workforce development, and again, consistent with today. And in terms of successes, I think I come from an industrial background. I want to see harmonization in standards. It's a good way for them to become used and actually applied. So having ASTM and ISO having a joint partnership, I think, is invaluable. And once you have a suite of standards, and I appreciate that standards, they've come on a long way. I'd say we've probably got a bit more work to do, which keeps it interesting. But when you have a suite of standards, you can then certify against standards. You can train using standards. And it becomes a really good lever, because I don't write them. Christian doesn't write them. But the audience, the users of Additive, it's a consensus-based process. So that input into standards, that raises all ships. And for me, that is a very good, robust, tested way that we use globally. And that's used in Europe, US, etc. I think that's a very powerful tool we have.
A language we can all speak. Johannes.
Yeah, I mean, I will jump on that. We had that throughout the WEF, World Economic Forum discussions last year. well, we had that idea or created that idea of some sort of superconnector, because we have enough initiatives around the world, and we can double, triple, or quadruple those activities, and the outcome would be relatively low, I guess. And we should not forget that standards in the past were also made to protect regions. They were not meant to align all of the global. They protect regions. And this is sort of a chicken-egg problem. So I will not judge again whether the protection reflex is good or bad. We just have to accept that it was like that in the past. And we will not change it just by a finger snip. We have to accept that. We have the global, the non-global, the regional standards. But what I think is really needed is some sort of global connector to just see what is done where, because the activities are so numerous, even in that small industry, that really we have, I think, every topic is covered at least by 10 times by anybody. And we really cannot manage to fold it. We need some sort of super organization to get that done. That would be my vote for that, some super connector.
Damien Buchbinder.
We have to make it short. So standards, ASTM, ISO, VDMA, MGA, and so on. There are lots. So standards in general will help. And perhaps even more important, that AM becomes normal in the production world and not something special. And that we get used to it. So a mind change that is everywhere. Perhaps it's even more important to drive AM than standards.
Thank you. Christian Seidel.
Yeah, I'm a bit biased probably as chairman of ISO TC261. I've been part of this committee for more than 10 years in the meantime, being the chairman for 3 years. And what we try to do is we try to create an international community. Currently, we do the math every half a year, so we're looking at maybe 2,000 international experts coming from around about 35 countries. And we gather these experts twice a year in order to develop standards. I totally see the point of the history of standards, that's for sure, but Michael Süß said this morning, it doesn't make much sense to fight over a small pie, but to make the pie large, and I think we're still in this phase. So, and creating a larger pie, we tried to come up with a very powerful structure at our ISO ASTM collaboration to provide a platform for international experts to solve their everyday problems. In our case, by writing a standard. I know they have some more problems in terms of costs, sure, but the problems we can solve, I think we created a very good platform, and in the meantime also organizational structure. So this can really help the industry to solve their problems in their everyday business, so that not every single customer-supplier relationship needs to be negotiated individually, but can rely on standards. This allows to scale. And once the pie is large enough, we might get new problems, but for the next 5 years, we will probably be busy.
Thank you so much. Paolo Gennaro.
I would like to have 3 points. First, standardization. I believe everybody agreed that the standardization was a great job and will continue in the future. Then, training of the people. I totally agree with you. Should be in every technical university, should be like all the other technology, so everybody will learn as is mandatory. The third thing that is not there, and a lot of people are wasting money at the local level, is that we are talking about, in most of the cases, design for manufacturing, but nobody's talking about the fact that there is also the design for manufacturing in terms of alloy. So everybody is developing its own alloy. Also, is the alloy are basically the same. You know, we have the Western alloy, the Chinese alloy, the Russian alloy. At the end of the day, are the same alloy, but just to avoid patents or to avoid some export license. So I believe if you want to grow additive, we should in some way collaborate and develop new alloy that are alloy that make sense for additive and are not feasible with standard technology. So we can use the big advantages, not only in design for manufacturing in terms of geometry, but in design for manufacturing in terms of new alloy. It's probably where we should collaborate, just to avoid everybody's developing his own Paolo Gennaro alloy, that will be your alloy, and everybody's doing the same job. At the end of the day, we waste money.
Thank you. Dirk Simon.
Well, I think learning from each other is the international initiative which we need to foster. And this AMTC is a learning exercise. Today we have seen these blueprints from the different regions, so we can learn from the different regions. And this, I think, is a good motivation to learn from each other and to bring that into an international initiative.
Thank you. very much to all of you for sharing your insights and for helping us to tease out. Actually, one last question to all of you. Did we, do you think, come to a consensus that there is more that the regions have in common than what divides them? If you say yes, raise your hand, please.
Yeah.
Yep, okay.
Yes and no. On a global scale, yes, but if we dive a bit deeper on a local scale, no. So, but we stay on the global scale, so yes.
Very good. Thank you very much. Let's give them a warm round of applause, please, ladies and gentlemen.